Okay, guys, in this lesson, we're going to take a look at squares that are not perfect squares, and we're going to estimate the root. So when we talk about estimating or approximating, that means we're going to have a decimal as an answer. And remember, we're not going to use a calculator for this lesson. So again, it's very important that we memorize our perfect squares. So if you do not have those memorized, at least have the list out in front of you. So let's just go through these. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. So let's review finding the square root when we have a perfect squared number. So the square root of 121, or undoing something that was squared, is 11. The square root of 196 is 14. The square root of 225 is the same as 15. The square root of 144 is 12 times the coefficient 2 gives us 24. The square root of 64 is 8 times the coefficient of 3 gives us 24. We have negative 2 times the square root of 100, which is 10, negative 20. We have 1/2 times the square root of 324, which is 18. Half of 18 is 9. We have 1/3 times the square root of 81, which is 9. 1/3 of 9 is 3. We have 1/4 times the square root of 400, which is 20. 1/4 of 20 is 5. 4 goes into 20 5 times. 5 times 1 is 5. The same here as 1/3. 3 can divide into the 9 3 times. 3 times 1 is 3. Okay, but what about when we have a number like the square root of 12? As you can see, the square root of 1, the square root of 4, and so on. So you can see that the square root of 1 is actually 1. The square root of 4 is 2 on our number line. But the square root of 12 is not a perfect square. So we're going to learn how to estimate about what the square root of 12 is on the number line. So the first thing that we need to do is take a look at the square root of 12 and decide between what two perfect squares does the square root of 12 lie between. So the square root of 12 is going to come between the square root of 9 and the square root of 16. So somewhere between the whole number 3 and the whole number 4 is the square root of 12. So the square root of 12 is sandwiched between the square root of 9 and the square root of 16. This is just saying the square root of 12 is greater than the square root of 9 and less than the square root of 16. So that's the first step, is to decide between which two perfect squares does our non-perfect square lie between. So now that we have established between what two squares does the number fall between, we are going to establish as the square roots. So again, we have the square root of 9, square root of 12, the square root of 16. So this is the first statement we are going to write. We know that the square root of 12 comes between the whole number 3 and the whole number 4. So on the number line, somewhere between 3 and 4 is the square root of 12. And again, we're going to find the decimal. So to find the decimal part, we know that we have 3 point something because the square root of 12 is between 3 and 4. So it's going to be 3 point something. So now let's find that something. So the square root of 12 is between the square root of 9 and 16. So first I have my 3, my whole number. Now we're going to find the fraction part. So the fraction comes between the distance between the two perfect square numbers. So 16 minus 9 is 7. So we have a denominator of 7. The numerator is going to be from the first perfect square to the number that we are estimating, the square root of 12. So there's a distance of 3. So the square root of 12 is about, so I use the squiggly, is about 3 3/7. However, we are told to find the decimal. So we have to convert this fraction to the decimal part. So this is 3 divided by 7. So we're going to divide 7 into 3. 7 goes into 3 0 times. 7 goes into 30 about 4 times. 4 times 7 is 28. And usually they will say round to the nearest tenth. So we can go ahead and go one more decimal place value out. And 30 minus 28 is 2. Bring down another 0. And 7 into 20 almost goes 3, but we're just going to say 2. So our final answer is going to be 3 4/10. So the square root of 12 is about 3.4. So on the number line, it would almost be right in the middle. So about right here is the square root of 12. It's almost at 3.5, but about 3.4. Okay, let's try our second one. We have the square root of 30. So I'm going to first just set up my statement, my inequality. So the square root of 30 comes between the square root of 25 and 36. So the perfect square before 30 is 25. The perfect squared number after is 36. So we know somewhere between 5 and 6, okay, is the square root of 30. So somewhere between 5 and 6. So our number, the square root of 30, is going to be about 5 point something. So let's find the fraction part. So the denominator is the distance between the two perfect squares. So 36 minus 25 is 11. That's our denominator. And then the distance from the first perfect square to the number we are estimating is our numerator. So we have 5 and 5/11. So that's the square root of 30. However, we need to convert the fraction part to a decimal. So 5 divided by 11, that's dividing 11 into 5. The top goes inside the box, and we're always going to round to the 10th. So 11 goes into 50 about 4 times. 4 times 11 is 44. We're going to subtract, bring down a 0. 11 goes into 60 about 5 times. And because this hundredth is a 5, we can round this tenth, this 0.4 to 5. So we're going to say the square root of 30 is about 5.5. So about right here on the number line is the square root of 30. Okay, let's try another one. So we have 72. Let's go to see if we can just use a pointer. Nope. Okay, so 72, again, the first step is to find the two perfect squares. So 72, the square root of 72, comes between the square root of 64 and the square root of 81. So our math statement is going to be square root of 64 is less than the square root of 72, which is less than the square root of 81. So we know the square root of 72 on the number line is between 8 and 9. So it's going to be 8 point something because it's between 8 and 9. Now, let's find the fraction. So the denominator, again, is between our two perfect squares. So we have 81 minus 64, and that's going to be 17. And then the numerator is the first perfect to the number we're estimating. So that's going to be 8. And now we need to convert this fraction into a decimal. So we're going to divide 17 into 8. So 17 can't go into 8, but it can go into 80. So if this 17 were 20, I would say about 4 times. Let's see if that works. So 4 times 7 is 28. 4 times 1 plus 2 is 6. And so when we subtract this, we get 12. So 0.4, and now I'm going to bring down a 0. And now we're going to divide 17 into 120. I'm going to try 6 times. 6 times 7 is 42. And then 6 times 1, that's 10. I think I could go up one more time, but either way, what this is telling me, it's really going to be a 7, but it just tells me to round this 4 to a 5. So the square root of 72 is about halfway between 8 and 9 on the number line. And so right here is where we could plot the square root of 72. It's about 8.5. Okay, let's do another one. So the square root of 6 comes between the square root of 4 and the square root of 9. So we have the square root of 4 is less than the square root of 6, which is less than the square root of 9. So we know it falls between 2 and 3. So it's going to be 2 point something on the number line. So let's find the denominator. 4 from 9 is 5. 4 from 6 is 2. And so we're going to convert our 2/5 into a decimal. The top goes in the box. So 520 is 0.4. So this is going to be about 2.4. So 2.4 is almost in the middle, but we'll say about right here is the square root of 6. Okay, let's do another one. The square root of 42 comes between the square root of 36 and 49. Now here's the thing, guys. I have this number line on each page of our lesson, but remember, you're not going to really have this list of perfect squares. That's why you have to have these memorized. And anytime you're taking a test or a quiz or even just a handout, I would go ahead and write out all of these perfect squares at the top of my paper. So the square root of 42 comes between the square root of 36 and the square root of 49, which is between the whole number 6 and that whole number 7. So it's going to be 6 point something. So we have the square root of 36 and the square root of 49. So our denominator, 49 minus 36 is 13. 42 minus 36 is 6. And now we're going to convert 6 over 13 into a fraction. 13 divides into 6. So 13 can go into 60. Let's try 4, maybe 5. 4 times 3 is 12. 4 times 1 is 4 plus 1 is 5. Note that worked. And then 13 into 80. Let's try 6. 6 times 3 is 18. So I'm going to round that to 0.5. So it's halfway in the middle. Now, it just seems that every example we've done, our final answer is about in the middle. That is not always going to be the case. Also, if you've noticed, and I want to bring this up, I brought it up to my other classes, that every problem we've had so far, our numerator has been the exact same number as the whole number. This is just by coincidence. So this we could have been estimating the square root of 43 and our top number would have been 7. Okay, so that just happened in each one of my examples. Okay, now let's just do these two problems and we'll be done. So we are comparing to see if 7 over 3 is greater, equal, or less than the square root of 5. So first let's convert 7/3 into a decimal, and then we'll compare decimals. So we're going to divide 3 into 7, top goes in the box. So 3 goes into 7 2 times. 2 times 3 is 6. Bring up our decimal, and then 3 into 10 goes about 3 times. So this is about 2.3. Now let's sandwich the square root of 5 in between the square root of 4 and the square root of 9. So we know that it's going to be 2 point something. So our denominator is going to be 5. Our numerator is going to be 1. So 5 into 1 is 0.2. So this is about 2.2. So 7/3 is a little bit greater than the radical 5. Okay, the square root of 18. So the square root of 18 comes between the square root of 16 and the square root of 25. Again, I have my list of perfect squares at the forefront of my mind or also on paper. Okay, so it's always good to have these numbers listed. And I should put square root of 1 at the beginning. Okay, so we know this is going to be 4 point something. The denominator is going to be 9. Our numerator is going to be 2. So 4 2/9. And we convert that to a decimal. Top goes in the box. So 9 and a 20 is about 2. So far, we'll just say 4.2. We may need to take it further. 24/5 is the same as dividing 5 into 24. So 5 goes into 24 4 whole times. 4 times 5 is 20. We're going to subtract, bring down a 0, and 5 into 40 is 8, 4.8. So radical 18 is less than 4.8.